In this example, we will be factorizing a squared minus ab minus ac plus bc. Factorization is the process of writing terms as the product of their factors. This is done by finding the highest common factor amongst the terms. In this example, we will be factorizing the first pair and the second pair separately. The coefficients of the first pair is 1. The highest common factor of 1 is 1, and 1 is implied, so we don't need to put it down. We now find our highest common factor of our algebraic variables. In the first pair, this is a squared and ab. The highest common factor of a squared and ab is a. I now find the complementary factor for each term in the pair. What can I multiply by a to get a squared, or a into a squared? The answer is a. What can I multiply by a to get negative ab, or a into negative ab? The answer is negative b. I now move to the second pair, which is negative ac plus bc. The coefficients in this pair is also 1, and the highest common factor of 1 is 1. 1 is implied, so we don't need to put it down. So I now find the highest common factor amongst the algebraic variables, which is AC and BC. The highest common factor of AC and BC is C. I will be factorizing negative C, and you will see why shortly. I now find the complementary factors for each term in the pair. What can I multiply by negative C to give me negative AC, or negative C into negative AC? The answer is A. What can I multiply by negative C to give me positive BC, or negative C into positive BC? The answer is negative B. Factoring out negative C gave us the complementary factors of A minus B, which of course is common to our first term. Now that we have A minus B common in both terms, we can factor it out. So A minus B, and we follow the rules of factorization here. What can I multiply by A minus B to give me A times A minus B, or A minus B into A times A minus B? The answer is A. And what can I multiply by A minus B to give me negative C times A minus B, or A minus B into negative C times A minus B? The answer is negative C. So we have just factorized A squared minus AB minus AC plus BC into its two factors, A minus B and A minus C. That is my answer. In this example, we will be factorizing 4x squared minus 16. When factorizing, pay close attention to questions like this. Here we're presented with two squared numbers, 4 and 16. So my first step is to change them into their squared notation. I know that 4 is equal to 2 squared. I have x squared minus 16 is equal to 4 squared. Here, every item is squared, so I can rewrite this as 2x minus 4 all squared. I can see that this is in the form of the difference of two squares, so this is equal to 2x minus 4 times 2x plus 4. So we've just factorized 4x squared minus 16 into its two factors, 2x minus 4 and 2x plus 4. And that's my answer. In this example, we will be factorizing 3x minus 8y minus 4xy plus 6. Here we're presented with four terms. By observing the coefficients of each term, I notice I could rearrange them in pairs, where the coefficients are factors of each other. So rewriting the question, we have 3x plus 6 minus 4xy minus 8y. I shall now factor the first pair and the second pair separately. In the first pair, 3x plus 6, I will find the highest common factor of the coefficients, which is 3 and 6. The highest common factor of the coefficients is 3. 3x is the only algebraic term in the pair. Therefore, I will now find the complementary factor for each term in the pair. What do I multiply by 3 to get 3x? Or 3 into 3x, the answer is x. What can I multiply by 3 to get positive 6? Or 3 into positive 6, the answer is positive 2. I now move to the second pair, which is negative 4xy minus 8y. My first step is to find the highest common factor of the coefficients. In this example, this is 4 and 8. Well, the highest common factor of 4 and 8 is 4. I notice that both my terms are negative, so I will be factoring out negative 4. My next step is to find the highest common factor of the algebraic variables. In this pair, this is xy and y. The highest common factor of xy and y is y. My next step is to find the complementary factor of each term in the pair. What can I multiply by negative 4y to give me negative 4xy? Or negative 4y into negative 4xy? The answer is x. What can I multiply by negative 4y to give me negative 8y? Or negative 4y into negative 8y? The answer is positive 2. I notice that I have x plus 2 as a common factor in both terms, so I can factor it out. X plus 2. My next step is to find the complementary factor for both terms. What can I multiply by x plus 2 to give me 3 times x plus 2? Or x plus 2 into 3 times x plus 2? The answer is 3. What can I multiply by x plus 2 to give me negative 4y times x plus 2? Or x plus 2 into negative 4y times x plus 2? The answer is negative 4y. We have just factorized 3x minus 8y minus 4xy plus 6 into its two factors, x plus 2 and 3 minus 4y. That is my answer. In this example, we will be factorizing 6y squared plus 13y minus 8. This expression is a quadratic. We know this by the y squared term. We know that this expression is in the form ay squared plus by plus c, where a is the coefficient of the y squared term. In this example, this is 6, where b is the coefficient of the y term. In this example, this is 13, and c is our constant. In this example, this is negative 8. We now use a, b, and c to complete our sum product table. The sum column is equal to b. In this example, this is 13, and the product column is equal to ac. In this example, this is 6 times negative 8, which is equal to negative 48. So, we need to find the factor pair of 48 that when I add, I get positive 13 and of course multiply to get negative 48. So I need to list the factors of 48. The factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and of course 48. I will not be going through each factor pair to determine which one best suits my sum product table. With enough practice, you too will be able to identify the factor pair by just listing or watching the factors of your AC. In this example, this is negative 48. So, I know that the factor pair 3 times 16 is best suited for my sum product table. Well, I need to get negative 48. So I need one of these terms to be negative. And when I add them, I need to get positive 13. So the negative factor must be 3. Negative 3 times 16, that is equal to negative 48. And negative 3 plus 16, that is equal to 13. So the factor pair is negative 3 and positive 16. When I multiply them, I get negative 48. And when I add them, I get positive 13. Now that I have my factor pair, I can rewrite my quadratic expression as 6y squared minus 3y plus 16y minus 8. I will be factorizing the first pair and the second pair separately. The first pair, 6y squared minus 3y, I will start with the coefficients. My coefficients are 6 and 3. The highest common factor amongst the coefficients is 3. I now find the highest common factor of the algebraic variables in this pair, which is y squared and y. The highest common factor of the algebraic variables is y. I now find the complementary factor for each term in the pair. What can I multiply by 3y to get 6y squared, or 3y into 6y squared? The answer is 2y. What can I multiply by 3y to get negative 3y, or 3y into negative 3y? The answer is minus 1. I now move to the second pair. My first step is to find the highest common factor of the coefficients. In this pair, this is 16 and 8. The highest common factor is positive 8. 16y is the only algebraic variable in the pair. So my next step is to find the complementary factor for each term in the pair. What can I multiply by positive 8 to give me positive 16y, or 8 into positive 16y? The answer is 2y. What can I multiply by positive 8 to give me negative 8, or positive 8 into negative 8? The answer is minus 1. I notice that I have 2y minus 1 as a common factor in both terms, so I can factor it out. 2y minus 1. I now find the complementary factor for each term. What can I multiply by 2y minus 1 to give me 3y times 2y minus 1, or 2y minus 1 into 3y times 2y minus 1? The answer is 3y. What can I multiply by 2y minus 1 to give me 8 times 2y minus 1, or 2y minus 1 into 8 times 2y minus 1? The answer is positive 8. So we've just factorized 6y squared plus 13y minus 8 into its two factors, 2y minus 1 and 3y plus 8. That is my answer.